Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week, and we are talking about eclipses. There's going to be a total solar eclipse across parts of the country coming up a week from Monday. But I'm recording this at 1:38 a.m. and if my hair looks all out of place and I'm unshaven, it's because it's just been that kind of a day, and it took me forever to make the graphics that I wanted to make and get them to work the way I wanted them to work. So if I sound frustrated, I am, but we're going to get this thing knocked out. So let's go on ahead and put myself down here in the corner, and here we go. So some fun eclipse facts, if you will. The sun is about 400 times as far away from the Earth as the moon is, okay? But conveniently, the sun's diameter is about 400 times as large as the moon's diameter. So the bottom line is they end up appearing to be about the same size in the sky to the human eye. Now, math, as you might expect, helps us to understand a little bit more about eclipses. So let's say we have two objects. The one on the left is the Earth, and the one on the right, let's just say for the heck of it that it's the moon. And so we have the distance from the center of the Earth to the center of the moon. And we have an observer standing on the surface of the Earth looking at the moon, and you can look at the moon in a couple of different ways. You can look at it as the diameter across it, which is the actual distance, or you can take a look at it as the angular distance. Okay, if you had a circle that went all the way around your head, then the number of degrees that would be swept out by the way you see the moon, okay, is the angular distance, and that's what we're looking at here from this line to this line. This is the angular distance here, and that's how big it appears to us based on where we are and how far we are away from the object that we're looking at and how big that object is. Okay, so if we take the ratio of this little yellow arc right here, okay, to the entire circumference of that circle, okay, that is going to be equal to the diameter of the moon, the actual diameter, compared to the circumference of the circle that goes all the way around the Earth. Okay, so again, we're just taking a look at this small little portion here, that angle, compared to the 360 degrees that goes all the way around. Okay, and when we do that, this is what we come up with. So there's the Earth, there's the moon, and there's the sun. And I could not draw these to scale because the sun is so far away, so much farther away from the Earth as the moon is, that simply couldn't do it, or you wouldn't be able to see the objects. So we're interested in the distance from the Earth to the moon, and then from the Earth to the sun, okay? And then here is our angular look at both of them, and you can see that the moon fills up the distance from that top line to the bottom line, and the sun fills up its distance from the top line to the bottom line. So they're both appearing to be about the same size in the sky. So the apparent size of the moon compared to 360 degrees is equal to the ratio of the diameter of the moon to the circumference of the circle that goes all the way around the Earth, and the radius of that circle is the distance to the moon. So when you fill in the numbers, the diameter of the moon is 2,159 miles. The circumference of that circle that goes all the way around the Earth is 2 times pi times 223,607 miles. And by the way, that distance from the Earth to the moon and the Earth to the sun is changing every day. The orbit is not circular, it's actually elliptical. So the moon's distance, I think, varies by about 30,000 miles, and the sun's distance varies by 3 million miles, okay? And again, remember that we're closer to the sun in January and farthest away from it in July. Okay, so when you do all that math, the apparent size of the moon is 0.5532 degrees, okay? That's how many degrees are swept out by the way you see the moon. Okay, the apparent size of the sun compared to 360 degrees is equal to the ratio of the diameter of the sun to 2 pi times the distance of the sun, okay, or the circumference of the circle that goes all the way around the Earth and goes through the middle of the sun. We know the diameter of the sun is 865,370 miles, and the circumference of that big circle around the Earth that goes through the sun is 2 times pi times 93,144,150 miles. So the apparent size of the sun ends up being 0.5323 degrees. So compare those two numbers, the moon appears slightly larger than the sun and thus is able to completely block it out. Now, at other times of the year, the moon actually appears smaller than the sun, and there's no way you can get a total eclipse in that kind of a situation. So the moon has to be at the proper distance from the Earth as well as the sun so that the moon appears slightly larger than the sun and therefore is able to block it out completely. And the length of time that it is blocked out has to do with how much bigger the moon appears than the sun, okay? I think the maximum is a little bit over 7 minutes. The minimum, I think, is, I don't know, 1 or 2 minutes. And this time, the maximum totality, as you look at that path across the United States, is about 4.5 minutes. So sort of in the middle of that range. But it's definitely longer than the last one. In 2017, I think the maximum length was 2.5 minutes. So it's going to be almost twice as long, right in the middle of that path of totality. All right, folks, there are the credits. That is your bonus weather video for this Monday. The next one will be coming up Wednesday. Next daily weather update, I can now tell you, will be coming up later today. So you all have none of you are going to see this now, I doubt, but when you wake up and hopefully take a look at this, hope you have a wonderful Tuesday, and we'll talk to you later Tuesday afternoon. Take care, everybody.